Hello dear students. Let's prove another language not to be CFL using Pumping Lemma. Now here we are given a language L which is a raised to n, b raised to m, c raised to n, d raised to m. That means number of b should be equal to number of d and number of a should be equal to number of c. Given n and m both are greater than or equal to 1, now this language is not a CFL. How do you prove it? First thing is let L be CFL. Then let P be pumping length. Now you have to consider some word W element of L, but length of the word should be surely greater than or equal to P. Then the word that you can consider is A raised to P, B raised to P, C raised to P, D raised to P. Oh my God, you might say, but sir, here we were given A raised to N, B raised to M, you notice, and you are making the superscripts equal over here, equal. But you will fully agree that this is also part of L. Why this is part of L? Because number of B is equal to number of D and number of A is equal to number of C. I hope you are understanding. If you don't like this word, no one has stopped you. You can take A raised to P and simply B, C raised to P and simply D. Now you tell me, isn't number of B equal to number of D and isn't number of A equal to number of C? And surely the length of this word is also greater than or equal to P. That was the condition, isn't it? This is the condition. And the length of this word is 2 times P plus 2. Just check the number of characters. Some word like this you have to take which will be element of L, and surely the length of the word will be greater than or equal to P. So I have taken this word A raised to P, B raised to P, C raised to P, D raised to P. And we should be able to break this into U, V, X, Y, Z. But length of V, X, Y can be less than or equal to P. So what's my plan, I will assume that Vxy is this. I'll better write it again. A raised to P, B raised to P, C raised to P, D raised to P. This is the word. I'll assume that these P number of B's is together Vxy. So this is U. A raised to P is U. And this entire thing is Z. Have you preserved the rule? Yes. Length of Vxy is exactly P, and that is allowed. Length of Vxy can be at most P, isn't it? Okay. But then, okay, this entire thing is Vxy, but V and Y cannot be empty. So we can say let V be a single B. Let Y also be a single B. And then X will be equal to B raised to P minus 2. Obviously, from these PBs, we have taken 1B out. So P minus 2 B's are pending. So what's our plan? The W, which was A raised to P, B raised to P, C raised to P, D raised to P, has been broken in such a way that U is A raised to P. Correct? V is single B. X is B raised to P minus 2. Y is single B. Note, Vxy taken together is P characters, exactly P characters, and that's the rule. It can be at the most P. And Z is C raised to P followed by D raised to P. Now, what if we find a new word such that we say it is U, V raised to I, X, Y raised to I, Z, where I can range from 0 to any number. But whatever new word we are constructing should be element of L. What if it is not an element of L? Then you are arriving at a contradiction and you can say that the given language is not CFL. So what if you keep this I as 2? Keeping I as 2, the word we will get is U, V square, X, Y square, Z. But what is U? U is A raised to P. But what is V? V itself is single B, you observe. But you are repeating that 2 times, so you'll get B square. But what is X? X is B raised to P minus 2. That is B repeated P minus 2 times. But what is Y? Y is single B. But you are repeating it 2 times, so B square. And finally, what is Z? Z is C raised to P, D raised to P. Now the new word that we have got is A raised to P, B raised to P plus 2. Observe. C raised to P, D raised to P. This is not the part of L. This is not the part of L because number of B's must match number of D's. Hello. Number of A's are still matching number of C's, but number of B's are not matching number of D's. This cannot be part of L. We have arrived at a contradiction. We are able to prove this for I is equal to 2. You can even prove it for I is equal to 3 or 4. And you can even prove it for I is equal to 0. What if you put I is equal to 0 here? U, V raised to I, X, Y raised to I, Z. So you will get U, V raised to 0, X, Y raised to 0, Z. Correct? So what is U? U is, just check, U is A raised to P. What is V? Just check, V is B, but it's raised to 0. That means we are pumping out V. We are not going to write V at all. We are pumping out. When we kept I as 2 in this example, we were pumping in. We were extra pumping in the occurrences of V. Here we are pumping out. What is X, by the way? What is X? X is B raised to P minus 2. What is Y? Y is B. But we have Y raised to 0. That means we are pumping out Y. And finally, what is Z? Z is C raised to P, D raised to P. This is again not the element of L because number of A's are matching number of C's, but number of B's are not matching number of D's. Then the new word that we have got is not the part of L. That means our assumption that the given language is CFL was a big contradiction. I hope you have understood how to prove this language is not CFL. Thank you very much.